Thanks for coming to the talk. My name's Scott, and I'd love to talk to you about what's Q or what's new in Android security. I've been an Android developer for over 8 years now, and I care passionately about app security and mobile security. But probably like many of you in the room, I spend majority of my time when I'm developing, working on features, regular apps development, rather than specific security stuff. And I always find that no one ever says they don't care about security, but yet we're so often working on other stuff, functional requirements, visual niceties, app modularization. I mean, just look at some of the great talks at this conference. There's loads of stuff you can do to your Android apps, Kotlinizing it, whatever. So there's loads of stuff to do, but we don't often, I say, prioritize security. So that's where this kind of talk aims to come in, with trying to focus on the new security things that have come out in Android 10, Android Q, so we can make our apps, make use of those APIs, and really make our apps more secure and privacy aware. Or at least that was the theory kind of when I was researching this talk and writing it. But actually, what became more apparent, because Android has traditionally been a lot more open than, say, iOS, and with this kind of enhanced privacy and security that we're seeing in the several versions of Android to date, but specifically in Q, this enhanced privacy has meant like a tightening of things, which for some of us, for some of our apps, will mean breaking changes. And that's a big part of the content that I'm going to cover today. I'm splitting it into like 3 bits. These are the key areas from an Android Q point of view in terms of security. Updatability made the most sense to start with, but privacy is where the majority of the content is here. So with updatability, if we step back in time a little bit, and look at Project Treble, which came along in Android O. The real crux of Android Project Treble was this kind of red line that you see here, this vendor interface. And the whole benefit of that, it meant that OEMs like Samsung, Sony, or whoever could test their specific changes in isolation from the Android OS. So it made putting new system updates, testing them a lot quicker. And we can see this has really worked. And back in the days of Android O, we had the Nexus and the Pixel devices that ran the developer preview. We fast forward a bit to Android P, we see that there are 8 devices, 7 manufacturers. So as people start to roll those out and start to make use of Treble. In Android Q, we see 23 devices and 13 device makers. And also we saw that as part of the research for this, I found that Google were saying that the adoption of Android Pie was like times 2.5 more than Android Oreo. So it's working, and it's great. The more the more our users' devices are the later versions of Android, they're more secure, and that's and it allows us to make use of those APIs more. So the next sort of phase of this, which we're seeing in Android Q, is Project Mainline. And this aims to further segregate the system components so they can be updated independently via Play services, via the Play Store. So there's a bunch of components. I've picked out the 2 ones that would be of the most use or of interest from a security point of view. The media framework. If anyone remembers all the stage fright vulnerabilities from a few years back, now at least this framework can be updated independently. The media framework has always been one of those things that has access to lots of places of the system, and it's an area where Google have targeted for hardening. But it's great to know that that's separately updatable. And same with Conscript, which is the SSL engine, encryption engine that Android uses. So the focus here isn't so much full system updates, getting those quicker. That's really what Treble allowed. Project Mainline is that monthly security updates that they can be done independent of a full OS upgrade. So yeah, I think that's really good stuff here. And again, there's not necessarily so much we can, as developers, we can use in a day-to-day, but it's just more that the platform is getting to a point where it's getting more strong and it can be updated and patched more readily. So yeah, privacy, that's where the majority of the changes have occurred. And I've been doing this kind of what's new in security talk, for the last 3 years. Each year, new version of Android, and it's a trend. There's been tons to talk about from a security point of view. But definitely this year, there feels like there's much more on the privacy front, and as I said, much more in the sort of breaking changes arena. And to start with, I thought location is probably the best place to start when we think about users' privacy, our own privacy of our own data. Our current location is probably up there as the top one that they're concerned with. The changes in Android Q are really focused around access to that location in the background. So if you're accessing the location in the foreground, not much has changed. Same, business as usual. It's a runtime permission. You need to request access to that. The user gets a system prompt. They either allow it or they don't. And you still have to code around it, be defensive in case the user revokes it at some later stage. So that's business as usual. It's the background and accessing that location all the time, which is what's changed. So now we see the background location is the restriction is always in place in Android Q, and now when you want to ask for that, you get this tri-state dialog. As you can see, there's 3 options to either access all the time or just while the app is in the foreground. The other thing is, if a user grants you access, your app access to location in the background, they'll get a reminder from the system just to let them know that, hey, Google Fit has access to your location when it's not running or when it's in the background. And the user then can quickly go link from that directly to settings to disable that. So when you look at the docs and this, Google are really kind of key at pointing out that you need to gracefully degrade, handle the fact that the user may deny access and you never get to prompt them again for this. And if accessing background location is of critical importance to your application, you really need to make the case. The value of that to the user. You need to make the case in whatever copy and graphics or whatever you have before you prompt for that permission, so they understand that to approve that and agree to it. Yeah, and also if you haven't got the permission, making sure that you communicate that enough to users to go into settings and re-enable it. So there's a new background permission. This is fairly big news if you need this. What happens is you have to define this in your manifest if you're targeting Android Q. If you target P or lower, it's automatically granted if you have the location permission. However, it's worth bearing in mind that there's some kind of edge cases when the user's device is upgraded. Some of you may have experienced this already, as Android Q was out a couple of weeks ago. I put this table on, not so much for you to scribble down or anything now in the talk, but just as a link to it there. It's more that if accessing a location in the background is important to your app, then you're going to need to account for these edge cases, these upgrade scenarios, and the table really covers it all. So I'll leave that for you folks to go and check out. But yeah, it's really they've tried to do it in a way that sort of remains backwards compatible and doesn't just break straight away, which adding a new permission would by default. So it's nice that Google care about that. And we'll see that actually when we talk about some of the other restrictions. They really thought about not crashing, apps not crashing straight away on when the main OS is updated. But yeah, another just quick point on if you're using a location foreground service. So this is when you have foreground service is where you have to have a persistent notification on the screen. This has been kind of like adding more protection around it. So in the previous version of Android, they added a new permission around it. It's not like a dangerous permission. It's not something that you have to request at runtime. That could happen at some point. But I get the feeling that the idea here is a restriction, a tightening on this, and so it's just a reminder that you'll need to declare that permission. But also, there's a new foreground service type, and so they're trying to restrict it down. So there's different types of foreground service, like different use cases. Location is one of those, so that's totally legit. So an app like Strava or any kind of like or maps navigation, there's a foreground service type to sort of handle that. But yeah, just thought it worth mentioning in case that's the kind of location updates you need. So sort of segueing on to from location to another kind of area which has undergone huge changes between the previous version of Android. External storage. External storage has always been a bit of a Wild West kind of area, if you understand that analogy, because once you had like read-write access to the to external storage, you could happily overwrite apps from other files, files from other apps even. And when I've done security recommendations and stuff in the past, when I've sort of advised people, like if you're reading in content files from the SD card, you really need to treat that as untrusted, because another app or a malicious party could have edited that data. So you need to treat it as if it's coming from a untrusted source. So now in Android Q, we see a big change here, and it really depends on how much you use this in your app, whether it makes no difference or it makes a huge difference. And really the big change is you get this filtered view when you request external storage and you're looking at files and folders. You'll only see by default files that your app has created. And if you want to access other files, files from other apps, you're going to need to use something like the API via the media store, and you might get a clue in the name of what kind of stuff that supports. It really is geared up to photos, videos, and music. If outside of that, you'll have to look at the system file picker, and I'll show that just over the page. But one thing around like researching into the different storage permissions and stuff, it kind of raised this question, and it highlighted some APIs that have been around for a while, which are seemingly like not as well known. And so I'll run you through this table, and it's like, do you actually need storage permission? If you're an app that's say downloading DRM'd content that you want to keep out of the internal storage because you don't want to fill it up too much, because on the lower end devices that's particularly can be a pain point for users. You can put that in external directory without needing the permission for external storage. That's the get external files directory method. So it's an app-specific directory, but it's you don't require any permissions to access that, and it's completely it's removed when your app is removed. So I think that's quite a nice one, and that was for me personally. I didn't know that existed. So that's quite handy. The restrictions and the changes are around, it's mainly accessing apps from files from other apps. So if you're just accessing your own files, you don't need that permission. And if you're like I kind of mentioned, if you're accessing files that don't fit into those buckets of being media, you're really left to the storage access framework, popping up the system file picker effectively and getting the user to select that. So this could be like huge, depending on your app. If you're an audiobook player and you rely on the files being downloaded and propagated from other apps, you're gonna have to do some big refactoring. I think in acknowledgement, actually, this whole thing changed a little bit as throughout the developer previews. And I think acknowledgement of the fact this is a big change for some people. This is potentially hugely breaking. There's a way of just completely opting out of this. So you can put this attribute in your manifest file, and it just restores to the old way of doing it. So I think this is a good example of Google caring about backwards compatibility and not suddenly, once a user updates to Android 10, suddenly everything breaks and stops working. But I'll just flag that warning a little bit more emphasis on that. You know about this now. This is coming in Android R, whatever, Android 11. This scope storage, this filtered view is going to be required for all apps running on the device, regardless of what target SDK. So now's the time to put it in your backlog. Now's the time to start working with that and making sure this is in place and on, installed in the majority of your users' devices, prior to the release of this. So you have been warned. Google's put this opt-out for now to give you time to do it. But it's not just external storage that has these as restrictions. Connectivity gets a few little restrictions, and this will only impact your app if you're doing certain things. But it's worth mentioning. And there's a new kind of like funky system UI to sort of enable stuff. If you're used to setting the Wi-Fi enabled, you can do that programmatically. If you're used to doing that, you can't do that anymore. It's now on Android 10. It will always be set Wi-Fi enabled, will always return false. And you can't manually input Wi-Fi configurations anymore. This, for me, is a real shame. I worked on an app years ago where we built a Wi-Fi finder app for a telco in Europe. And we built like an iOS app and an Android app. And the Android app, it was one of the things that we as Android developers could like one-up the iOS team, because we could manually add those configurations in, so the user could then just walk within range of this cafe or hotspot, and they would be automatically connected. Whereas the iOS team had to go and prompt the user, and they had to type the password in. So it's a shame this is going away, but I can kind of get it from Google's point of view, and from a user's point of view. If they've chosen to not use Wi-Fi or to use Wi-Fi, then apps having control of that doesn't really necessarily gel well. It's all about the users being kind of more in control. One sort of caveat here: you can still do that if you're a device policy controller, like device admin. Like that's for like a mobile device management sort of system. So that's still possible, and that kind of makes sense for a device owner or a device profile to be able to do that. But regular apps that probably most of us are developing in the Play Store aren't going to be able to do that. You can still, if you need to add Wi-Fi configurations, you can use the add suggested network, and then you get like a broadcast back to say that's connected. This didn't work very well in the developer previews, and I don't know, haven't had a chance to test this, so I'd be interested if anyone's used that. And it works great or doesn't work. I'd be interested to hear that afterwards. So what do you do if you want to do this? You have to use this settings panel, and this is again, it's all about giving the users the choice. This launch is effectively part of the system app. You just fire this intent. It's easy to do, and then they select whether they're going to enable internet. This is the internet settings panel. There's one specific for Wi-Fi. There's one for NFC and volume. And I wonder if we'll see more settings go into this way, rather than you be able to directly access that. And I seem to recall from one of the Android fireside chats at Google I/O, the ability allowing third-party developers to access and change settings was probably one of the things that the Google engineers at the time were sort of saying was probably a mistake. And I think this is part of them, restricting that and giving the control back to the user. There is apparently a AndroidX wrapper coming in. I mean, I'm sure it's going to be super simple. It's just going to be a case of checking if you're running Android Q, you do this settings panel intent. If not, you just launch a settings app. But that's coming. But yeah, so that's kind of what it looks like. So next, I just wanted to cover the non-resettable hardware IDs. And this is one of those things that has been, over the last couple of years, we've seen the restrictions coming, and they're getting things like build serial number. That used to be a field on the build file. Then it turned into a method that was protected by the read phone state permission. And now, spoiler alert, it's gone completely. You can't access that. It's now moved into a read privileged phone state. And if anyone's familiar with that keyword privileged in terms of Android permissions, that's really system only. That's not something by default or by generally that you'll get if you're in the in the Play Store. There is so IEM number as well is included in that. The whole point of the previous restrictions or previous changes as well, like the Android Secure ID, changed from being like unique per device to being unique per app signing certificate. So that changed in I think the last version or the one before. These are really the last two identifiers that you can use to identify the hardware. Now access is going. Also, the MAC address is now like randomized. So you really, as apps now, we can't really get that ID of the device, and that's good from a user point of view, from a tracking point of view. The caveats or the kind of exceptions here, again, if you're a like device admin policy owner, app running on the device, you can still have access to this information. And there's something called carrier apps, for phone networks, that there's a special carrier permission that carriers can apply for. I'd never heard of it until researching for this talk, but yeah, which kind of makes sense that something like that would exist for them, for their apps to be able to get hold of your IEM number. That kind of makes sense, but for most of us in this room, if we're using those in anything at all for tracking, maybe we're doing some, I've seen it used in a voting system for like a TV thing like X Factor, where they wanted to reduce the barrier of entry by not having a login, and so they've used things like hardware IDs to stop people voting multiple times. They're going to have a hard time now. So if you're if you target Q, you're going to get a security exception because you don't have that permission. If you're targeting below Q and you attempt to access it, you're going to get a null or just some dummy data. And obviously, if you don't have the read phone state permission, just like any permission, you're going to get a security exception. Yeah. So, I think this is like the most kind of severe, I guess, in terms of change. Now you're getting an exception. But this has been coming, from very early days in Android. We were told not to use this, the device ID and generate and install ID, that kind of thing. So this is not new, or not shouldn't be a surprise to most of us. But there's plenty more stuff to talk about, and I kind of the rest of it just kind of a bit quick fire and a bit random of other security things that may be useful for your apps and your contexts that I couldn't really fit into a category. So this is Misc. One bit of good news is now TLS 1.3 is supported by default, and this the properties of this you don't really need to know on a low level, but it almost never happens in security. Something's more secure and quicker. That's pretty cool. Of course, your API will need to support this. If for some reason you can't control that, you might have to manually force SSL to use a lower version. I just put that for information. I wouldn't recommend you do that. It's better to use the stronger, newer protocols. There's also, while I was sort of digging through stuff to see what else had changed, I noticed that HTTPS URL connection, the set socket factory, has changed slightly. Now it'll throw an exception if you pass a null to it. It used to be that's the way you set the default settings. Probably most people in this room are thinking, I use OK HTTP, I never worry about this sort of stuff. But this is more for maybe probably aimed more SDK developers. If you've worked on SDK and you don't want to add another dependency, you'll have gone with using you might have gone with using sort of native HTTP stack. And so you might be finding, if you're seeing this illegal argument exception in your crash logs, this could be why on Android 10. But I just thought I'd flag that as it's something that that came up. And there's actually a proper method to set this, like set default socket factory or something, which we should all be using. It's just, top up voted Stack Overflow answer is set, past null to it. So now you know. There's another enhancement for running your DEX code directly from the APK. There's a kind of attack vector where you could, on a compromised device, you could potentially, when an app's installed, this is all unpacked from the APK and then run locally. There's a chance that could be manipulated and changed. This aims to just try and stop that, so it's run directly from the APK. To enable this is just like a manifest option to use embedded DEX. It can't be compacted because there's nowhere to unpack it because you're running it directly. So you have to set an option in your Gradle config to make sure that you're not compressing it. And Google are quite vague about what this, reduced performance, they say. And yeah, who knows what that means. So I would say, like, if security is important to you in your app, it's worth trying this and then testing it and running it against benchmarks and seeing if it makes a huge difference. But yeah, it's vague. But yeah, it's an interesting new feature that you could use. There's a bunch of stuff, bunch of new things within the non-SDK interface restrictions. And for those who aren't familiar with that, it came in the last Android version, and it's really Google sort of locking down the use of us using reflection and JNI to access and change things within the SDK that were, not meant to. These are hidden; they're not in the documentation, and there's basically a bunch of more restrictions in Q. Here's the link to the massive list that it is. Way too much to, even on a screen this big, it's way too much to put up there. And it's quite hard to process it, actually, even if you just got it on your laptop screen or whatever. The best way of I've found with dealing with these restrictions is to turn on the strict mode policy, and then you get however you want to react to that. I just tend to do on our development builds. We run that, and it's in the logs, and you spot it. I think in general, you're not putting strict mode on to detect your own use of this. When you've used reflection to do something, you've wrapped it in try-catch statements, to find if field not found or method not found. You're doing something a little bit dodge, and sometimes you need to because I've used it in some views where something isn't particularly hasn't been isn't a public method or something. You've needed to do something to fix a bug, and I've definitely seen this in library codes on GitHub. So I'd recommend, even if you haven't got this in any of your code, that you turn on the strict mode, detect non-SDK API usages, and then that can help you identify potential crashes in the future. Because if anything is on that blacklist, you'll get, it will crash. So I think that's quite a useful tip. And there's a Misc restrictions in the Misc section. Background activity starts are now forbidden and blocked. So this could be, say, I don't know, you had an email app, I don't know, that downloaded an attachment that then launched it like in an intent service or something, and then launched it as soon as it was downloaded, and it, you go away from the app while it's downloaded. That's not going to work anymore. That'll be blocked. And the recommendation from Google is to instead, once that file had finished downloading, is to fire a notification. The user then can choose to whether to, how to react to that, to open it or ignore it. Again, it's giving the user more choice about what they do. And of course, notifications for the last couple of Android versions is very easy. If you get too chatty and send too many notifications, it's very easy for users to block, per channel, or turn them off completely. So you have to be wary of using that too much. Access to the clipboard. So this is another one of those Wild West areas of Android which kind of goes under the radar. But previous to Android Q, any app can just register for clipboard changes. Copying a password from your password manager and pasting it somewhere. Any app can just register for changes. until now, until Q. So now the restriction is it's only the app in focus that can access the clipboard, as well as the default input method editor, the keyboard, effectively. So that's quite a good restriction. It sucks if you're a clipboard managing app and you synchronize that with some other web service. Yeah, I don't see a way around that. But yeah, I think that may affect your app, may not, but I think it's a good thing from a system point of view. And then just lastly on here is the system alert window, which is another one of those things that I think Google have come out and publicly said, yeah, this was kind of like turned out to get abused. It's often been abused for like tap jacking and things like that. On Android Q, that permission is no longer usable. On Android Q Go devices, that's the key difference. On Go devices, this is no longer, you can't, your app can't receive that permission. For those unfamiliar with Go, Android Go, it's kind of like it's a version of Android targeted for lower-end devices, primarily targeted at manufacturers selling their devices in developing countries. India is a good example where Go has done well. And the idea is Google do a bunch of the heavy lifting for the OEMs so they can bring the cost of the device down. They handle the updates and stuff like that. And Google get their services to the next billion users. So but what I mean is they have more control over the system. So they've been able to do this in Android Q Go. But I wonder if we'll see this in the main Android system in the next version. I wonder if this is a sort of guinea pig to see how it goes. If you do need this, if you're already installed on the device and you're using this permission and the device gets updated, you'll still retain it. But if your app is uninstalled and reinstalled, you won't get this permission again. So it will only affect a subset of you, but it's a big deal if you're targeting these regions. And it's not all kind of doom and gloom, not all restrictions. We do have a new encryption library that we can use, AndroidX security. I'm super stoked about this. It's a new way of us, if we want to store data, encrypted data at rest, we can, there's two implementations, encrypted file and then encrypted shared preferences. It uses safe defaults. It uses AES 256 GCM or AES GCM 256, whatever, how you want to say it, which is, last time I checked, was the de facto, the one you should choose, the most secure in theory. And yeah, it's super easy to use. Like, unlike other libraries like Bouncy Castle or the JavaX security, very powerful, very robust encryption libraries, but really steep learning curve to use. With this, there's pretty much just one option, and that's the default. So really, that's great to see. So all of us developers don't have to be, have tons of crypto knowledge to be able to just encrypt our file or our shared preferences. It is minimum SDK 23. That's part of the fact it's based on it uses encryption from a library called Tink, which is a Google encryption library, and part of that uses the Android key store, and which requires 23. That being said, if you still need to support users on lower devices, you could offer this for devices for 23 plus, and then just offer regular shared preferences for users below that. No point not offering this say encrypted shared preferences to all your users just because you need to support like 1% of devices which are below 23 and probably will never be upgraded. It's just worth bearing that in mind. Or it could be a good emphasis to push your minimum SDK up. Security is a good justifier for bumping that minimum SDK. Devices getting, the newer devices are more secure. The newer Android versions are more secure. So use that in your meetings and discussions with clients and with with stakeholders. So just quickly, how you would use this. You generate the keys very easily using this master keys like helper class. Then you just I should have mentioned the other thing is that it's in alpha. So it's an alpha library, alpha 2 at the moment. That may affect whether some of you run to use it or give it a little bit of time. This is how you create it. Very easy. It adheres to the shared preferences interface, so you can very easily just swap it in and change the, this could be in your Dagger module or something, and you just return the shared preferences. You might notice it uses different encryption schemas for the keys and for the values. That's because the values one is non-deterministic. In that sense, it generates a different ciphertext each time, which is good, more secure. The key one needs to be the same each time because it's like a hash map to look it up, so it has to be the same each time. So your access token key needs to resolve to the same ciphertext each time, so you could look it up. Under the hood, this is what it looks like. I just used Stetho, Facebook Stetho, just to pull that out. It's interesting to see that, so it's quite, gobbledygook, and you wouldn't understand. As an attacker, it's not going to be easy to sort of pull out that token or email address or whatever you've stored. So before you jump in and encrypt all the things, you've got to think about, do you need to migrate all your preferences? Probably not. I mean, you're not going to be able to use the preference activity, preference screen, that kind of thing with your encrypted shared preferences. So you probably only want to, encrypt and use it for personal information, email address, and access token, that kind of stuff. And don't forget, think about like a strategy for what happens if the decrypt fails. The key store, even though this is completely hidden to you when you're using this library, is a bit temperamental, especially on the older devices. Luckily, I mean, this library doesn't support before M, but it can be temperamental, especially if you've like removed all the fingerprints from the device and then re-added them. That can cause issues with the key store. So, like for my use cases when I've used encryption, it's mainly been around caching content offline there's a copy of on the server. So worst case, if the decrypt fails, the user has to re-authenticate and they have to re-download that stuff again. Not a big deal. Bad UX, yeah, but if it's failed because the key store is corrupt or whatever, there's not much you can do about that as a developer. But you have like recovery, code for it, catch exceptions and take the user back out to the login page. If you're an offline only like password manager and the decrypt fails, it's a completely different story because how are you going to get that stuff back? I don't have the answer to that, but just to make you think about, what's your recovery option in case it doesn't work. So yeah, hopefully you're similarly excited as me. This first kind of Google Android-specific encryption library, and it should be really good. And lastly, I just wanted to cover the platform hardening points. This isn't necessarily something we can make use of on a day-to-day or APIs from our apps, but it helps us, the newer versions of Android, more secure, that kind of mantra. There's a really great article, way too much detail to go into in a talk, but if you're interested in that, I would highly recommend reading this from May. It talks about how they're separating like the software and hardware codecs and how they've built in like memory sanitizers and stuff. It's quite cool. It's quite geeky, but yeah, highly recommend reading that. And the other thing that is it built into Q now is the Adiantum, which is an open source library which aims to bring like disk encryption to the lower end devices. So again, this isn't an API you can like use so much. This is more the fact that part of the reasons why the Android devices aren't, encryption isn't enabled by default on some, especially the lower end ones, is because they need this AES hardware chip to make it, to make it viable, to make the performance viable when you're using it. That restrictions goes away because Adiantum doesn't need that chip. So in Android Go devices, smartwatches, TVs, file and disk encryption should be seamless now. So that's brilliant, and it's part of the platform. So it's it'll be there. So when your watch or your TV gets the Q update, it could be used. And super graphs. I've included graphs, so I've ticked that box as a presenter. So that's really it. Hopefully, you've seen some new changes that some breaking changes, but some changes that you can see that others up the priority and not ignore them. And even if you're busy doing features, there's still a place for security in that backlog. But if you leave here with just like one thing, it's this privacy checklist that that Google released. It was, it's been a basis for the talk. There's been some really interesting stuff in it. This is what it looks like. This is the link to it's above. It really covers like the key behavioral change, the app, how your app is affected, how you might mitigate that. And this is the kind of thing you sit down with your team and make sure that if you're using background location, how you go about resolving that and how you do it properly. It's a really, really useful guide. And with that, thanks for listening.